Okay, so today we've come to our third session of this unit. Can you see my screen?
Yes, I can see your screen.
What are you seeing on the screen though?
I'm seeing the assignment group.
Oh, you can see assignment brief. Okay, good. I'm sharing the right screen. Okay. So today we in our third session. So what's going on? So what did we do in our previous tutorial? We spoke about Amazon web services. We looked into them, about the different type of services that are provided by Amazon.
Yeah.
And then we gave a couple of examples of them, and we looked into the dashboard of EWS. So in today's session, we're now looking into more technologies that are used by you are using cloud computing and DevOps, so by cloud engineers or DevOps engineers. So these technologies that we're going to learn today are called Docker and Kubernetes. So these technologies are used mainly by cloud engineers and DevOps, and these technologies are used by companies like Google, obviously AWS. So we can find this Docker and Kubernetes, which has been used also by companies like Facebook and Netflix. So this is a good technology, which it is really useful. It is really good to learn. And today we'll look into them. We'll understand the fundamental of container, and we're going to install Docker. So we're going to understand why these companies, these big corporate, they use this cloud computing technology. Then 3.2, we're going to be able to build our Docker images from scratch and maintain the vulnerabilities using the scanning tools. Then we're going to look into proficiently install Kubernetes in the cloud as well as the local system. Then we're going to understand and apply container management with scalable, high available, secure, automated, cost-efficient technologies using Kubernetes. And then lastly, we're going to understand different Kubernetes service and patching in cloud. So as we have now introduced, we have this technology, this cloud computing technology, and we're now going to understand why they are important and why they are so much used by these big companies. So what is Docker containers? So as we see, Docker is an open source platform that automates the deployment, scaling, and management of applications. So basically what it does, we now have applications, and as a developer, for us to ensure that there's no any sort of delays, or there's no any sort of clashing with other system, we'll now introduce containers. So containers is simply a way for us to package our application. So containers are lightweight, portable, and consistent environments that run software reliably across different computing environment. So by us creating these containers, we can now isolate our application from the whole environment. We can now ensure that if one application crash, not all the system is going to crash because we are isolating the path when it comes to developing and deploying. So what are the benefits of Docker containers? We run application consistently across different environment. Isolation, so we're now going to isolate application from each other and the underlying infrastructure. Scalability, so this will be easy scale application horizontally. So this was the example I was telling you. So for instance, if we're going to run some updates, and instead of us to launching it all across all the platform, across all the systems, we can now do it for one system at a time, where we're now isolating the application and they don't communicate between each other. So it'll be easier for us to deploy them. What is Kubernetes? So let's not confuse Docker with Kubernetes. So Docker allows us to package our application by packaging them, creating containers, while Kubernetes is simply a management tool. So when there is a lot of traffic in our containers, that's when we now start using Kubernetes to regulate the traffic. So it's simply a management tool that allows us to manage the amount of traffic. So what are the benefits? Is automated deployment and scaling, self healing, load balancing and service discovery, and storage orchestration. So conclusion, Docker and Kubernetes together provide a powerful platform for deploying, managing, scaling containerized application. So Docker simplifies the process of building and running containers, while Kubernetes automate the orchestration, management, and scaling of these containers.
When you
In
say
the
containers, what do you mean?
containers, as I said, they call them containers, but it's simply analogy, makes you understand that we are just simply going to isolate applications. So we are creating a package that's going to isolate applications so they don't crash between each others. Say you have one application for deployment, or you have an application for testing or whatever, and you don't want them to crash with each other. We'll now use Docker. So we're now going to isolate them and they don't communicate with each other. So we just putting them into a package. That's why they call them containers. So we're also going to have a small demonstration where I'll show you the steps that you need to cover for you to create our containers. So again, here we have an example of what the benefits of containers. So these containers are lightweight, portable, and consistent environment that include everything needed to run software. So they will now have the code, runtime, system tool, libraries, and settings. So Docker is the most popular containerization platform that simplifies the creation, deployment, and management of these containers. Okay, so how this work? These containers package application and its dependencies together, ensuring that it runs uniformly and consistently across various environments. So let's have a demonstration of how Docker works. So we now have to head to Docker website. Hold on, what is that? UK Versity here. So you now head to Docker. So this is the website of Docker. You now have the option of downloading the application. Docker document. 1 second. So from here, you have the option download desktop for Windows, Docker desktop for Windows. So this is what you need to download. Once you've now downloaded Docker, there are a couple of things that we need to enable first. So what we're going to enable first, we need to go into command prompt. Are you familiar to the command prompt?
Yeah.
Yeah. So on your command prompt, yeah. So at the moment I have mine. We're now going to check if we have. So there are a couple of things we need to install first. We need to install Windows subnetting for Linux. And to do that, we first have to go to turn Windows feature on and off. So once we get this window, we need to ensure that Hyper-V is selected. Then you scroll down to virtual machine platform has to be selected. And then Windows subnetting for Linux. So by having these three selected, you now click on OK, which you now save. And then we'll now run WSL.
Will this be on the module, this recording?
Sorry?
Will this recording be on module?
The recording.
Yes.
Yes. So
Okay. That way,
everything.
and
Yeah. So by typing WSL install, we're now going to check if we have this package installed. So what it's doing now, we're going to install Ubuntu, which allows us to create images. So this will take a while. So it's now checking, just let's give it some time. It's 50%. Almost 100. Okay, so as you can see, Ubuntu has been installed. Once this whole steps is done, you now have to download Docker Desktop for Windows, which I already have installed on my machine. And now I'm going to launch Docker Desktop. So there you go. I did not sign in for privacy purpose. So once create Docker, so what I've done on the command prompt, I've now installed Docker on my machine and Ubuntu. So this is still loading. Let's wait until the installation has been completed. Installing this might take a few minutes. Uh, Please create a default. Why is it crashing now? Okay. Welcome to Ubuntu. Use the desktop. Okay, let's just allow that one at the moment. So let's check Docker. Yeah. So now we have, what is Docker again? Now that we have Docker, actually, let's see if I can put it. Okay, so I'll give you some basic commands that you can run with Docker. So on command prompt, what I did, I typed Docker, which shows us that we have Docker, we have successfully installed it, and it gives us some basic command for us to create our packages. So let's run some basic commands. So we have Docker run hello world. So here we have simply created our first image. As you can see, it has popped on here on our container. So we have created our first container, and we called our first container hello world. So these containers are images. So we can also check the version of Docker that we have installed. Docker version. So as the recording, as of now, where is it going? Okay. hyphen version. Did I type it correctly? Version. Unknown shortcut. See Docker help. For some reason, it's not giving me this command, but it should be. Is it? Oh yeah, my bad. I made a mistake. So it's Docker double hyphen version. So it says Docker version installed is 26.1.4. So we have checked the version which is installed as of now. And now let's run some other basic commands which enables us to pull images from the Docker repository. So we're now going to tap Docker pull Ubuntu. So we're now going to pull images. So what do you think will happen now by pulling these images? What happens is that we're just going to create images here. So what happened is that the system has now pulled from images from the Docker repository, and it has fetched and saved the images into the system, as we can see from here. So what the command we can run now? We can create containers from the images as well. So what we'll do now, we're going to run another basic command, which is docker run ATHE-ID. Yeah. So we've now created a container, which is this one here, and is running at the moment. So this is the new container we created with this command, run ATHE-ID Ubuntu. So now let's create a list of all our running containers. So we can now type docker yes. As you can see here, now we have a list of all our running containers. And now we're going to show the running containers at the executed containers. So docker yes a let me maximize the page. Okay. So with the next command, we're now going to display them. So what do? We type docker exec -it, then we'll now copy our container address, paste it here. But now we're going to exit this. So the next command will now should technically be used for us to log in into our Docker account, and once logged in, you can now upload all our instance, all our images into the Docker Hub. But I did not sign in into my account, so this step cannot be taken further. So this was a short tutorial which shows us the basic commands for us to create our containers. So as you can see, we have containers, and we're able to generate these images. So this is how this technology works. So this was a short demonstration of it. So we've built our Docker image. And now I think we've covered this as well. Building Docker image from scratch, maintaining security and deploying. So since I did not log in into the account, the deployment cannot happen. But this is the whole concept of building containers.
I'll probably need to look through the recording again and again until I understand it. But this aspect of the course,
Oh yeah,
is it part of the second section where you have to start, the practical part?
yeah. So
Obviously, I don't know, I won't know how to give them access to this area. Do I have to record myself doing it?
say that again. You have to what?
Do I need to record myself doing this so that way I can show evidence that I did the Docker
From the assignment.
for the assignment? Yes.
He
Or is it
says
just something I need to explain?
describe detail
Where
about what
containers?
are containers, networking security and containers. Describe containerization and orchestration. Elaborating the benefits of orchestration tools like Kubernetes. Explain about Kubernetes provisioning deployment. Section B, provision cloud service, AWS. Deploy Docker images from Jenkins pipeline into Kubernetes cluster. Configure ingress in Kubernetes cluster. What was your question again?
I thought, would this be part of the practical, recording myself doing it? Or is it all code that I have to send?
It's very up to you. If you feel like maybe creating a presentation, a PowerPoint presentation showing the steps that you did.
Okay.
Yeah. Section B, I think a PowerPoint too. So we can do section A Word document, the way you normally go and describe, explain. And section B, you can make a PowerPoint presentation where you show how you created your project.
I see.
Yeah. Also, you can go through the, the website of Docker, where it says get started with Docker. It shows you step by step how you get started to the deployment. So you even explain what they want to cover about Windows subsystem for Linux, where I showed you how to install that. Then you were able to, it's pretty straightforward, installing Docker on your machine. Then there's Docker Hub, where obviously you have to create your account and so on for you to upload your containers. Where's my presentation again? Yeah, so now let's look into the containers management tool. So we explain what Kubernetes is, which is an open source container management tool, which automates containers deployment and is used to manage the load of traffic. So it is a architecture, as we can see, and it consists on several key components that work together to provide them robust and scalable infrastructure. So, as I said, it's a management tool, so it allows us to avoid our system to crash. So whenever our cloud engineers are developing and deploying, they will now use this architecture in order for everything to work efficiently and to streamline the deployment of applications. So we do need to look into some of these concepts, such as masternode, where our masternode is responsible for managing Kubernetes in cluster, and we will now coordinate all activities such as scheduling, scaling, and updates. And also, we're going to have our API server, where it's going to expose the Kubernetes API, and it is the entry point for our REST command used to control the cluster. Then we'll have a controller manager, which will now runs controller process that handle our routing tasks. Then we'll have other key components such as scheduler and etcd. Also, after a master node, we'll have worker nodes. So what they do, they run containerized application, and they communicate with our master node and execute the task assigned to them. So we have kubelet, kubeproxy, container runtime. So let's look into Kubernetes.
What will be the better cluster to install, or does it matter?
Say that again.
Which cluster would be wise to install then?
Which cluster? The one we're going to install is Minikube.
Okay, that's the most that's the most well known then.
Yeah. So if we head to the website of Kubernetes and we go on to learn Kubernetes basic, you give us the whole explanation of what it is. So what can Kubernetes do for you? With this modern web service, user expect application to be available 24/7, and developers expect to deploy new version of those applications several times a day. So containerization helps package software serve these goals, enabling application to be released and updated without downtime. Kubernetes help you make sure those containerized application run where and when you want, and help them find the resource and tools they need to work. So Kubernetes is the production-ready open source platform designed with Google's accumulated experience in container orchestration, combined with best of breed ideas from the community. So this is the basic modules where we create our Kubernetes cluster, deploy our application, then we can now explode the application, expose the app to the public, scale up the application and update the application. So here it says create a cluster. So Minikube is what we say that we will be using. Learn about cluster. So here there's a whole glossary of what has to be done. And using Minikube to create a cluster. So this page here shows us what we have to do using Minikube to create a cluster. So what we'll do now, we have to head to Minikube. So I've already downloaded Minikube on my machine. So let me go back to Docker, delete. So we now delete our containers here. So now also delete the images. Deleting. So as we all know, our Minikube has to communicate with our Docker. So first of all, step one, we download Minikube, which I already have on my machine. But we don't run Minikube from our normal command prompt, but we run it from the PowerShell, from Windows PowerShell, which is our command prompt with administrator rules. So we now copy our command, Minikube start, PowerShell, boom. Boolean based image. So okay, so let's get back to the where's Minikube website. Okay, Minikube start, interact with Minikube. There's the image. There's
So
two
all
faces.
these people and the cluster and things, so that's like back-end code of how to manage codes.
Yes. So basically, the whole concept is for them to develop and deploy applications.
The management of cloud.
Your voice is very low. Can you say that again?
There's a database for the cloud that you're managing.
We're not actually creating a database. So what we
It's the backend of the cloud.
no. So for instance, we first create an application using programming language, Python or anything else. And for us to what do you call it? We'll now create packages. So this application is independent. So it's not communicating with other application. So we now, after we have created our application, we now package it. We now use Docker to package the application, and then we will now use Minikube to deploy this. So as you can see, now it has now been created. Creating Docker container. You see, because I deleted the one we created before. Oh, it's gone. So you see, we're now creating our container from Minikube, from our managing tool. And this will take a lot of time. Docker Minikube container is missing. We'll creating a Docker container. Okay, while this is creating, let's get back to our presentation. So the steps, as we see, installing Kubernetes cluster. So first of all, we'll install Minikube, install kubectl, start Minikube, verify the installation from his website. And then there are other type of clusters installing. So we could use Google Cloud SDK or create GKE cluster. So for this tutorial, we're using Minikube. This will take several time. But yeah, so from Minikube, step 1, download and install. So which I've already done. From our command prompt, we'll now run Minikube start. And then once that has created our container into Docker, we can now interact with the cluster. So these are more commands that we can put on our command prompt. For instance, we will now install kubectl get PO and so on. And here is the command for us to deploy. So we can simply copy this, paste it into our command prompt and run it to see how the deployment happens. And then it shows you in what port this will be visible. So this will be on the local host 7080. And then we can manage our cluster. So these are the commands used to manage the cluster. Also, once we've done all these procedures with Minikube, we can now look into Kubernetes dashboard. So obviously we will now have to copy Minikube dashboard and paste into the command prompt. And this will now take us to a web page where we'll see a whole dashboard for the deployment. This is to verifying Kubernetes component using image. Yeah, this is a very, very tedious and long process. Running. Enabling default storage class. Return an error. Running callback. Sudo storage. Process X. Enable dashboard. Start our cluster. Let's see if we are able to interact with the cluster. Minikube start creating. Couldn't get the correct server API group list. Why is it not connected? Okay, so this cluster is not creating at the moment. Okay, this cluster is not creating at the moment, but these are the steps to follow. I hope the procedure makes sense to you, Joshua. Hello? Joshua?
Hold on here.
Oh, you're still here. I hope the procedure to creating the cluster makes sense to you.
It's a little bit confusing. I can tell that it involves a bit of a virtual machine kind of manner.
Can you speak louder? Then I can't hear.
I said it does involve some aspects of virtual machine,
Yes,
like Linux.
exactly. Yeah.
Yeah, I may have to look through multiple types of tutorials to try and understand it because it's not something I can quite grasp with just one.
Yeah. It's
I'm
not. It's,
watching you, but I have no idea what, it's
yeah.
like jumping a lot of gaps that I need to understand.
Yeah.
It's the
It's not straightforward. Yeah,
It's
that's
not
the thing.
straightforward. That's why it's going to be uploaded online, so that way
Yeah.
I can grab it.
Yeah. Exactly.
So yeah,
Yeah. Yeah.
that's
As you said, you have to go through the recording and even the documentation of Kubernetes, where it takes you, you get you started with the basic commands, and you take you step by step for you to understand how this cloud technology works. So these are all stuff we spoke about. Yeah, so our presentation also talk about understand different Kubernetes service and patching in cloud. So what are the key Kubernetes object? They have pods, deployment, service, ingress, network policies. Yeah, so this is everything for today. So as I said, it's best for you to go through these documentations here and read and try to understand how these clusters are deployed. And if you have any issue, just pin me, let me know, then we can look into this.
Okay. Well, tomorrow I'd like to be more focused on the Amazon web services and how to set it up.
Yeah, exactly. So tomorrow, which is our final session, now is more, we're going to look into Linux virtual machine.
I see.
Yeah. So
Okay.
tomorrow's session is we're going to be able to use tools and standards for Linux system fundamentals, command line interface, and user group management.
Yeah, but inside that Linux virtual machine, wouldn't you need to set up the cloud for the
Oh
assignment?
yeah. Of course. So
That's
we
what
have
we do then.
in our virtual machine, we'll set up all our environment here.
Yeah. Okay.
Okay then. Is there any
Okay.
other question for today?
No.
Okay. So if there's no session, if there's no question, I'll just end the session.
All right. Take care.
Thank you for joining. Have a good day. Bye.
Thank you.